Hi, this is Rodolfo Eric Angat, your teacher in Earth and Environmental Science. Today we'll be learning about river system and erosion. Our essential question for today is how do river flows affect the rate of erosion and deposition? With this lesson, we aim to accomplish the following competencies. The first one, I can describe the distribution of water on Earth. Second, I can describe a watershed. Third, I can explain why rivers and wetlands are important. Fourth, I can define and describe tributaries, divide, meanders, and river delta. Fifth, I can explain how erosion creates meanders. And lastly, I can define and explain the importance of riparian buffers. Let us begin by describing the water on Earth. Our planet is called a blue planet because 75% or even more of our planet is covered with water. We have a lot of water on Earth and we are very lucky to have this much water. However, 97% of the water on Earth is salt water. And salt water or seawater is non-drinkable. That means we cannot drink it. If we drink salt water, we become thirstier. So it won't help us. We cannot also use salt water or seawater to irrigate farms. We cannot use salt water to water the plants. They will die. We cannot also use salt water in most industrial places because it will cause the machineries to rust. So salt water is almost unusable to us. What we really use is fresh water. But 97% of the water on earth is salt water. So this leaves us 3% of fresh water. However, 2.5% of this remaining 3% is frozen as ice. So it is also unusable, leaving us only about 0.5% usable fresh water. This 0.5% usable fresh water is distributed on Earth in the following. Again, 97% of the water on Earth is seawater, 2.5% is fresh water but it is frozen, and the remaining 0.5% or even less is found in aquifers or groundwater, rainfall, natural lakes, reservoir, and rivers. So we only have limited amount of usable water known as fresh water. That's why we really need to take care of our water. Let us help one another not to pollute it. So how do we get our fresh water? We get our fresh water from precipitation, and the land around us is the one that collects this precipitation. The land that collects the precipitation is what we call as the watershed. Again, I reiterate, a watershed is a land. It's a land area that collects the precipitation. Precipitation, by the way, includes rain and snow. And the land collects this precipitation, and the precipitation becomes runoff. Some of this precipitation is absorbed by the soil through the process of infiltration and percolation, some of which become runoff and goes to the rivers and lakes, and some of which return to the ocean. The watershed is the one that collects this water and directs it to the places where we get the water. So what is a watershed again? A watershed is an area of land where all precipitation that falls on it drains to a river or to a lake or to the ocean or is absorbed by the groundwater, of course. So the land that you see around you is part of a certain watershed. And there are different watersheds around us, And each watershed is divided by a high elevation of land, which we call also as a divide. We'll be learning more about that. And this is a watershed divide. So this is a watershed here, a watershed here. The one that has a higher elevation here that divides the two watershed is called the watershed divide. So again, we collect our precipitation, and this precipitation becomes our source of fresh water. The land collects this and channels it to rivers and lakes. These are the parts of a river. The beginning of the river is called the beginning of the river is called the river source. It is also known as the headwater. The river source or the headwater is found in the highest elevation. That is where the river begins. The water flows downstream, and the river has different parts. The river has tributaries. These are small streams that supply water to the main river, and these tributaries get their water from the watershed. We also have the floodplain. The floodplain is an area that is sometimes flooded with water, of course, and sometimes it's dry. It all depends upon how much precipitation falls from the sky. We also have the meanders or the bends in the river. So again, these bends here, we call them meanders. And then we have the wetlands that are close to the mouth of the river. And then of course the ending of the river is the mouth. And then we have the delta here. The delta are the sediments that are deposited by the flowing water. So these sediments came from the river source or headwater. They also came from the river itself, and then they got deposited here through the process of deposition. And then this is the ocean. The part wherein the seawater mixes with the fresh water is what we call the estuary. And the estuary itself is a type of wetland. Let's continue. Now this is also another picture showing us the different parts of the river. So this would be the headwater right here. The watershed is all the land around the river. A tributary is a small stream that supplies water to the main river. And this is called the floodplain because this area gets flooded when there is too much precipitation. This is a meander because this is a bend in the river. This is a marsh. It's also a wetland. And then this is the river mouth. And of course, here we should have the delta. Okay? Now, these are the tributaries here. This is a tributary. These small streams supply water to the main river. So, a tributary is a small stream supplying water to a larger river or to a larger stream. And these are the tributaries. This is the headwater. This is the main river. This is a bend in the river. We call this a meander. These are the delta. These are actually sediments deposited by the water flowing in the river. And then the ending of the river is the river mouth. And this should be a lake or an ocean. Now, a river has three main courses. We have the upper course. This is where the rapids are usually found. The water here flows very fast because of the high slope. And then we have the middle course. It's a little bit slower. And then the slowest part of the river is the lower course right here. Again, this is the delta. This is sediments deposited at the mouth of the river. Now, what's a watershed divide? Earlier, I mentioned this one. A watershed divide is the elevated boundary between areas that are drained by different rivers and streams. See, it's a long hill or a mountain that divides this area of watershed to this area of watershed. So we call it the divide. And these are other examples of divide. So this whole place is a watershed. All the land here is called watershed that collects the water and channel this water to the river. A watershed can also be fed by groundwater such as a spring. Spring is water coming from under the ground. So we call that spring. Of course, the water from the spring also came from precipitation, but depending upon the arrangement of the rocks and the topography of the land, some of the water under the ground can escape into the surface, forming spring. So again, this is a watershed divide. It is the land that separates each watershed. We call that a divide. Remember. What's an estuary? An estuary is where fresh water from the river merges with the ocean and is bordered by extensive wetlands, mudflats, or salt marshes. So an estuary usually look like this, and an estuary is a coastal water body where fresh water from the river and streams mixes with salt water. So the water here is what we call as brackish water, spelled as Brakis. So that's brackish water. Brackish water is a mixture of fresh water and salt water. Now here's the river. Oh, you see all these sediments being carried by the flowing water, and all these sediments are deposited in the river mouth right here. This area here is what we call the estuary because the salt water from the ocean mixes with the fresh water from the river, and the water here is a little bit salty, not too salty, because of the mixture of the fresh water and the salt water. Again, we call the water here brackish water, and this area with brackish water is called an estuary. As the water flows, more sediments are being brought and delta form on this place here. So an island forms here because of the deposition of sediments. Okay, fresh water as it flows, that's the estuary right there. This is the ocean water right there, and they meet, and where they meet is what we call the brackish water. You might be asking, how can the ocean water rise there? It can rise there because of certain natural events like tide. When it is spring tide, ocean water can rise and mix up with the river water, causing the mixture of fresh and salt water. Estuaries are very important to us because in this area there are a lot of different organisms. The biodiversity in the estuary is really, really rich. So there are a lot of different animals there, and many animals stay there because it is safer in the estuary, and that's why it is termed as the nursery for aquatic organisms. So if we destroy the estuary, a lot of living things would be losing their habitat and their safe haven in order for them to survive. So these are some of the reasons why estuaries are important. Estuaries are rich in nutrients. Estuaries provide places for animals to breed and raise their young. Estuaries support many kinds of plants and animals. Estuaries help provide the seafood that we eat. Okay, so these are just actually some of the benefits that we get from estuaries. When a river enters an ocean or lake, the velocity slows down and deposition happens. This is what we call the delta right there. See, that's the delta. So all the sediments carried by the water from upstream is deposited in the mouth of the river, and that deposition result to the formation of island And that island is what we call a delta. And the delta, again, is found in the mouth of the river. And here is the Mississippi River, and the Mississippi River right there. And then this is the Gulf of Mexico. And you'll see the delta being formed in the Gulf of Mexico right here. Okay? The delta is a landform that is formed at the river mouth due to deposition of sediments. Now let's see the major rivers in the United States. We have the Missouri River, the Arkansas River, the Mississippi River, the Ohio River. They all empty their water to the Gulf of Mexico, and all the water that flows here bring a lot of sediments. That's why an island is forming here, and that island is what we call a delta, okay, in the Gulf of Mexico. Now in North Carolina, so the river that passes our place, Winston-Salem, is right here. Okay, first on the western side of our place, this is Winston-Salem. On the western side of our place, we have the highest peak of North Carolina, which is Mount Mitchell. And to the east, we have the Atlantic Ocean, of course. This is where we are. Okay. The highest point in North Carolina is Mount Mitchell, and it has an elevation of 6,684 feet above sea level. The river that passes Winston-Salem is called the Yadkin River. And the Yadkin River is connected to the PD River, and it also ends up into the ocean. Cape Fear is a river basin, and it's the largest river basin in North Carolina. So let's see it here. This is Winston-Salem, that's a Yadkin River, and then in South Carolina, we have the PD River and also part of North Carolina right here. Okay. And then this is where the delta forms, because this is where the mouth of the river is. Okay. Now, let's try to answer this. A chemical plant in North Carolina leaked great amounts of toxic chemicals in the Yadkin River. What other river would also be poisoned by the toxic chemicals? A. Roanoke River. B. PD River. What do you think is your answer? So, this is the PD River, and that's the Roanoke River. And this is where the chemical leak happened. Which do you think will be affected? If your answer is PD River, then that is correct, because the water flows downstream, and the water flowing downstream brings the toxic chemicals to the PD River and then into the Atlantic Ocean. So the answer should be PD River. Now, Roanoke River is above there, and water in a river flow downstream, not upstream. Now, rivers, they produce more meanders when they age. This is a young river. It's straight. But as the river becomes older, it develops meander. So this is a meander, this is a meander, this is a meander. But as the river becomes older and older, it develops more meander and even oxbow lake. We call this an oxbow lake. An oxbow lake is a meander that was detached from the river. Okay, and then this is a rejuvenated river, meaning it was reformed. Now the cross section is like this. If a young river has a V shape, uh, V-shape river, but as the river becomes more mature, it becomes shallower but wider. So that is what happens. Again, this is an old river. This is a young river. Now look at the meanders of this river here. Meander, 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 meander. So definitely this is a mature river. Now, erosion happens when the flow hits the side of the river flowing downstream. This is how meanders form. See the flowing of the water? The rapid flow of the water on the left side causes this one to be eroded, and the slower flow of the water on the right side causes the eroded sediments to be deposited on this side, and then hits that side again. It erodes this and then deposits the sediments on the left side. See the flow? Okay. Erosion is faster when water and wind has more kinetic energy. And erosion is fastest on the upper course of the river because the water flows very fast. Meanders and oxbow lakes. A meander is a curve or bend in a river caused by erosion and deposition. So if you go back to this picture, this is deposition here and erosion here. Erosion here, look at this one. This is erosion. This is where erosion is happening. And this is where deposition is happening. Okay. So these are meanders. An oxbow lake is a U-shaped body of water that forms when the meander is cut off from the river. So a meander, a meander, a meander. But once the water recedes, the meander can be cut off from the river itself, forming an oxbow lake. Okay. Now, youthful rivers have this shape. It's a V shape. The upper course of the river is usually shaped like this. We call that vertical correlation. Now, the mature river does not have a V shape. It's more of a U shape because the water is flowing slower. And the type of erosion that's happening here is lateral corrosion because it's becoming shallower but wider. Unlike this one, it's a V-shaped river. Abrasion and corrosion is what's happening, and it's getting deeper but narrower. Now, I said earlier that we need to protect our watersheds. We need to protect our car parks, our schools, all the land around us. Why? Because whenever it rains, all the pollution that is found on land can be washed away by the runoff from the precipitation. All of this pollution, like if you threw your candy wrapper on the street, just imagine what will happen to that candy wrapper. When it rains, that candy wrapper can be washed away by the runoff and it will be brought to the river and lake and will pollute it. So everything that we put around us, like on the ground, on the street, all of this can be washed away by runoff and can be brought to the rivers and lakes, thus polluting them. That's why we need to maintain the cleanliness of our environment because our environment makes up the watershed. Let's continue. Now, another thing that you probably have noticed is that most rivers have a lot of trees and grasses and shrubs on both sides. So this is the river bank here, this is the river bank here. This is a healthy river. Why? Because it has these vegetations on both sides. These vegetations are what we call the riparian buffers. Again, we call them riparian buffers. Why are they important? Most non-point source pollution is removed from runoff by the plants, these plants here, this vegetation, before reaching the river or stream. So what's happening here is that the pollution from the community here, when the pollution here is carried by runoff, these shrubs and trees and grass filter that pollution before the water goes to the river on both sides. Now, this is a farmland here. The excess fertilizer is filtered off by the trees, by the shrubs, and by the grasses before it goes to the river. Thus, these trees or these vegetations here act as a protection so that the river will not get polluted by the non-point source pollution of the people living in this town and by the non-point source pollution from this farmland. Or this one, we can also say point source pollution because we know that the pollution is coming there. Now, now this is not a healthy river because the riparian buffer has been destroyed. See, the trees have died. Now this farm here, if the farmer here put a lot of fertilizer and it rains, the excess fertilizer will easily be carried by the runoff to the river and will cause this river to get polluted because the riparian buffer is no longer present to protect the river from non-point source pollution. Okay. Now, why do we have to protect our wetlands? The wetlands include the estuaries, and there are different wetlands that we'll be learning about in the future. Wetlands are important because they are not wastelands. Why are they important then? Just like the estuaries, they are nurseries for many different kinds of aquatic organisms and even birds and other animals. So it's a place for them to grow and to nurture their youngs. Another one is that it the wetlands prevents drought and they also prevent flooding. So they reduce storms, hurricanes, tsunamis by acting as a buffer. The coral reefs reduce speed and height of waves. Okay, flood protection too, as you can see here. Okay, so this is our discussion about rivers and the pollute and the erosion. Hopefully, you've learned enough so that you can get a good grade in our MC assessment. Thank you so much. Bye bye.